If you pay attention on this side, you will see two buttons here. One is logical, second is physical. The devices you see on the screen are in logical view. This is the logical view of our devices, which we configured, which we created here. That's why this button is white. This is the logical view of our devices, but we can switch to physical view as if we are using real devices, as if we are installing real devices in our rack. Just click here on the physical button and click home button here on the right side, upper right side, home button, and we'll see physical view of our devices, our router, our 3-hour switches, and additional power distribution device, this one. Okay, I can also click here on a router and configure it like in a logical view. It's the same thing. I can click here, configure it, go to command line interface, and so on. Click on switch, click on this switch, and do the same thing what I do in the logical view. I can switch between these views. Logical, I connect and do the same things. These devices are the same devices, but the view is different. So it's easy for us to see how can we install real devices on a real rack. How do they look like? It is good option in Cisco Packet Tracer. Okay, there's one good feature in this Cisco Packet Tracer which is called simulation. We can simulate our packets, our protocols, to see how packets going from one device to another device, and what happens with these protocols, with these packets. To go to the simulation, first of all, we need to configure IP addresses on devices which we are going to test. For instance, here's a PC. We are going to test connection between this PC and this router. So we'll send ICMP, I mean ping requests to this router and check connectivity between them. In order to do that, we need to give IP addresses to these devices, to this PC and to this router. If we click on router, here's a command line interface, our command line interface. Pay attention, the background color is white, the text is black. But in real devices, the colors are different. In real devices, in real Cisco operating systems, the color of a background is black and color of text is white. If you want to simulate real operating system, of course, if this color is comfortable for you, you can leave it. But if you don't like this view, you can change on real view. In order to do that, we are going to do the following. Go to options, preferences, choose fonts. Also, we can change the font size. I've already changed the font size. This font size was very small. It was 8. It's very small. I've changed it already to 18. You can change it. You can increase or decrease the size of fonts. And pay attention on these fields, colors fields. Router iOS text. What's the default color of router iOS text? Of course, it's black. Router iOS background. What's the color of background? By default is white. But in real devices, it's quite opposite. The router OS text color is white. The router iOS background color is black. So we'll change it, because as if we are using real devices. router text color will be white, router background color will be black. Apply, OK, click on router, voila, it's good. It's better. I think it's better than the previous one. We are using real operating system. Let's pretend that we are using a real operating system. Okay, this device doesn't have IP address. We need to assign IP address to this interface, gigabit 00. Our network will be 192.168.0.0. For example, if we are going to make some notes here, we click on this button, place a note, click here, and click on any space where you are going to put in the text. For example, I'm pasting text here, and I'm typing the network address 192.168.0.0/24 mask. And to get back to the selection, just click here, selection, and we can move this text all over the place. So in this case, our network is 192.168.0.0. This is our network between these devices. We are using this network, and we should assign IP addresses to these devices within this network. So IP address of this router will be 192.168.0.1. Let's paste it here. .1, and IP address of PC will be 0.2. Click here, move it a little bit here, somewhere here, and move it here. So we already know which we can see the interfaces, and we can see the IP addresses on that interfaces. It's good. So what we should do, we should assign IP address to this interface first on this router, gigabit 00. What I'm doing, clicking here, we are on user mode. Let's go on privilege mode, enable. Here's a good command, show IP interface brief. It's a good command. This command displays the list of our interfaces and shows IP addresses assigned to that interfaces. Also, it shows the status of that interfaces. For example, we can see here three physical interfaces: gigabit Ethernet 00, 01, 02, and one virtual interface. And their status here: IP address unassigned. As we can see, there are no any IP address assigned to the interfaces. Status: this interface is up because it's physically connected to our switch, but these interfaces are down. Of course they are down because there is no any connection. So we should assign IP address to this interface. Going to global configuration mode, config terminal tab. Going to interface gigabit Ethernet 00. We are going to configure this interface, so we are going to this interface, gig tab, interface gigabit Ethernet 0/0. We are already in this interface, as you can see. We are already in this interface. So I'm assigning IP address. IP address 192.168.0.1, and don't forget about subnet mask 255.255.255.0. That's it. I'm typing exit again, and show IP interface brief. Okay, it's good now. I have assigned IP address to the interface, and it's very good. Okay, I'm closing this, and assign IP address 192.168.0.2 to this PCs, to this PC IP address. Going to config faster than 0 IP address 192.168.0.2, subnet mask this one, and that's all. Okay, now I can try to ping from this PC to this router. Just click here, desktop, command line, ping 192.168.0.1, and as you can see, I have reply from the router. It means that there is connection is successful with the router. It's good. Okay, everything is fine. Now I'm going to simulation. I'm going to show you the simulation, how it works. Here on the bottom's right side, we can see simulation. Just press here. When I press simulation, we can see a lot of protocols which we can simulate here. Here is a big list of protocols which we can simulate, but we don't need them for now. So when I press this button, show all none, when I press once, it deletes everything. When I press again, it enables everything. So first I should disable everything, then I'm going to edit filters and choose protocol. For example, what we've done before this, we've done ping. We've sent ping from this PC to this router and get reply from this router. Okay, which protocol which protocol ping using? Of course, ping uses ICMP protocol. This is ping protocol. Ping, it's just a tool, but this tool uses ICMP protocol to communicate between devices. So to choose to simulate ping requests, we just check ICMP protocol here and close this. If you pay attention to this side, you can see ICMP appeared here. It means that we enabled only ICMP protocol. That's all. And don't forget to uncheck this box. Okay, it's okay. And now we should choose source, and we should choose destination, from which source to which destination our packet should go. So I press here this button. When I navigate to this button, add Simple PDU. As you can see, the name is add Simple PDU. PDU means Protocol Data Unit. Simple PDU. Here is a simple PDU and complex PDU. But in this tutorial, we need just simple PDU. I'm clicking just once on this PDU. Once. As you can see, the cursor of my mouse has been changed to envelope. I navigate here on my PC and click once. I've marked the source device and I'm clicking here. Okay, I've chosen source and destination device. So my envelope is ready. And what I can do now, I can press play. If I press play, the system will send ICMP, I mean ping request, which we've done before. The system will send ping request from this device to this device automatically when I press this button. When I press this button, we'll do it manually, step by step. from this device to this device, from this device to this device, from this to this, and from this to this, and back, of course, and back, because this device should send ICMP replies, which I showed you here. ICMP replies, I mean these replies. Reply. It means that our router sends reply back to us saying that it's okay, I'm available. So I'm pressing this button, and packet, as you can see, goes from PC to the switch. If I click on packet, I can see here fast Ethernet 01 receives the frame. Okay, fast Ethernet 01, this is this interface of the switch. It receives the frames. Okay, click here, next layer. The frame source MAC address was found in the MAC table of switch. This is a unicast frame. It means that this PC sends ping ICMP request to the specific device, to one device. That's why that's a unicast frame. Switch looks in the MAC table for the destination MAC address on its table. Next table, the outgoing port is an access port. Switch sends the frame out that port. So switch should send this frame out this port, faster than 03. Okay, to see this, just click here, and you can see the frame came here in the switch. And we click again. Information sent here, and information. This line is a backup line. That's why system is not using this line. It's default. It's on the idle mode. In the idle mode. Okay, press again. This packet reach the destination, right? And this router will reply this packet back to this computer saying that yes, I'm here, I'm reachable, it's okay. Okay, we can press this button, just play everything, and system will do it automatically. Play, goes to the switch, and from the switch goes back to the switch. As you can see, we can choose the speed of this player. Can you see the speed is more faster? Okay, so and if I click here in this button, small button here below, if I click here, we'll see the status successful. Source, here's all information. Source, this is PC, destination is a router, type of communication ICMP, color, it changes every time, and status successful. It's okay, it means that it is successful and okay. Clear event viewer. So we can just replay this. Replay, can you see where I'm replaying this? Manually. What's the information in this packet here? Gigabit Ethernet 00 receives the frame. The frame destination MAC address matches the receiving port's MAC address. The broadcast address, multicast address. The device decapsulates the PDU from the Ethernet frame. The device looks at the destination IP address table. The packet is sent ICMP packet. The process received echo request message. Okay, everything is good, and every information is here. You can just click and read this information to see what happens with this packet. Okay, we just if we press the delete button, we will delete this, and that's all. Okay, I'm going to show you additional protocol. just press here. If we are going to remove this, just press show none. That's all. It's none. It's removed. I'm going to show you ARP protocol, address resolution protocol. It means that this device is going to connect to some device. This device knows the IP address of that device, but doesn't know the MAC address of this device. So ARP protocol is used to get MAC address of device based on IP address of that device. So get layer 2 address based on layer 3 address. Click here Edit Filters, choose ARP Address Resolution Protocol, and close. We can see the ARP appeared here. And what should we do to test this ARP? To test this ARP, we should ping from this computer to any computer, to computer which is not in our network. For example, I'm going here, I'm trying to ping, and when I start paying attention on this side, I'm trying to ping 0.5. There is no any device with this IP address in our network. I'm pressing OK. As you can see, the packet appeared here. This is ARP packet. This is ARP packet because our computer wants to send ICMP request to this device. Our computer knows the IP address of this device, but doesn't know the MAC address of this device. As you know, devices communicate with each other with MAC addresses. So our computer is going to ping some device. Currently this device isn't in our network. Is going to ping this device. Our computer knows its IP address but doesn't know its MAC address. In order to get MAC address, it sends ARP messages to the network, asking every device about MAC address of this device, and see what happens here. I'm pressing here, press, packet goes here, click here, receive the frame, ARP ignores the frame, active VLANs not set up. There's a lot of information you can read. So finally, what does it mean? This is broadcast frame. The switch sends out the frame to all ports in the same VLAN except receiving ports. So the switch should get the MAC address of the device with IP address 05 and sends broadcast signals to all the ports to get this information. As this line is on the idle and this is a source address, so it will not send broadcast on the source address, of course. It will send broadcast to this address. There is no option. Click here, signals goes here, and this device also, this switch also doesn't know the MAC address of some device with IP address 1505. So this device should send broadcast signal to all its ports, but it has only two ports. One is source, which will not be used for broadcast. So this switch has only one active port, so it will send broadcast only to this port. Press this button and then you can see that it sends broadcast signal only to this port. So this switch also doesn't know information about MAC address of that device. And this switch has three active ports. One is source port, which we will not use for broadcast, of course, and this switch has two active ports. And of course this switch will send broadcast signals to each of these ports. got this ARP message. Pay attention on this side. Can you see? It sent broadcast signal to these ports. And here's the information. System cannot find. As you can see, so router don't have information about this IP address. Receives the frames, address, device. ARP process drops. The ARP process drops the frame. So this router drops the frames because it cannot find that device. And press again. Can you see? I'm pressing again, and this switch drops the frame as well, because none of these devices have information about IP address, about device with IP address 192.168.0.5. But what we saw here, it was an ARP request. So using different protocols, just edit filter, using different protocols, ICMP, DNS, gRP, IPv6 protocols, miscellaneous, there are a lot of protocols. You can choose any protocol you want and test it and see what happens. Press C, read, and get familiar with this information, detailed information, how packets, how protocols work, etc., etc. That's it for now. Thanks for watching.